All right, so as I said before I started recording, today we're talking about the problem-solving model, and we said our first step was to read the problem and identify the variables, and I asked you to list them on the left. So the reason I asked you to list them on the left, and really I want you to do this for every single problem. You know, I give you a problem, I want you to list out, just like I did on the board, what the variables are equal to. That way, it's going to assist you a lot in step 2. Okay, so step 2, what you're going to do is you're going to go to your equation sheet, okay, and based on the variables that you just listed, select an equation that has those variables. Okay, so if you list out variables v, t, d, and a, well then look through the equations until you see one that has v, t, d, and a. Okay, next up, and this is where we're kind of moving away from math class. Okay, we want to solve for the unknown, okay, in variable format. Okay, we're not plugging in numbers yet. All we're doing is manipulating the equation so that we solve for the unknown.
Bless you.
And note that says it may require substitution, and that's what we're going to be talking about today. Is how do we do substitution? Once you get an equation that has all the variables that you need and it's solved for the correct variable that you're looking for, then you just substitute in the values of the variables and you're done. Okay, we'll plug it in the calculator. Get an answer. All right, so if v is 3, then everywhere you see a v, you're going to put 3. So this leads us to the obvious question. What if I list out my variables, and then I go to look at my equation sheet, and there's not an equation that has the same variables as what I've listed? Okay, that's where we're going to have this may require substitution. Okay, so substitution is going to be custom building an equation for what you need. Okay. And the reason why we have to do this, I mean, yes, I could give you an equation sheet that has 9,000 equations on it, but that would be kind of difficult. So I guess I could just make it to where you type the variables you needed and it would come up, but that would be too easy. So we're going to use substitution to generate these equations. So substitution, the way it works. Okay, we're going to look at an equation and we're going to say, this one's close. Okay, maybe it has an extra variable, maybe it's missing a variable. To be frank, we don't really care if it's missing a variable. What we care about is if it has an extra variable. Okay, but let's say it's close, but has one extra variable. Okay, what we're going to do is use substitution to eliminate that extra variable. And don't write that. No, that's silly stuff. This is me writing it up there just to make sure I say it. Okay, so here's steps to substitution. Three easy steps. If you follow these, then you won't have any problems. The first step, guys, is to look through your equation list and find a base equation. When I say a base equation, I mean one that's pretty close. Okay, has most of what you need. Maybe has one extra variable, but pretty much is correct. Okay, set that equation aside for a little bit. Okay, so that one, I know I'm going to use this one, but I'm not going to focus on this one right now. Then what you're going to do, guys, is identify inside of that equation any extra variables. Okay, so maybe I'm using v and t, and I'm solving for a. Well, if I have an equation that has f in it, well then I don't have an f, right? Okay, so identify any extra variables. Once you identify the extra variables, find a second equation that has that variable and solve for that variable. Okay, so let's say I'm missing, all right, let's say I have an extra f. Okay, I have some equation, it has an f in it, I need to get rid of f. I'm going to solve a second equation for f, So let's say maybe this is, I'm just going to, I'll do an example in a second. It's going to get confusing if I do it up there. Okay, I'm going to solve in the second equation for f, and then substitute that into the other equation. Okay, so for example here, this is an equation for torque. I have an F here. Let's say I don't need F. F is superfluous. It's extra. I don't need it. Okay, so if I plug this F in here, do you see how this equation now is going to become? Now I don't have an F. Okay, I've eliminated F. I've used an extra equation to eliminate the extra variable. Okay? So let me do some examples of that. Alright, so let's say I'm asked to develop an equation with the variables v, vi, a, delta, and delta d, and solve for a. And I'm going to use these two equations here. I'm just going to, to start off with, just give us the equations just to make life easier. All right, first tip, when you're doing substitution, you can drop a delta. Okay, so for example, delta t. Okay, a delta t is the same thing as tf as long as your initial condition is 0. Let me kind of give you like a drawing of what I mean by that. I'm going to come back to that in just a second. Oh, no, I can't do it that way. I forgot when I'm doing the recording, I got to do it the other way. So, let's say I have a time window. Okay. Yeah. I cut myself on accident, and Patrick made it better. All right, so let's say my time window is from 0 seconds to 10 seconds. Do you see how delta t from 0 to 10 seconds is 10 seconds? And tf is 10 seconds? So as long as my initial is 0, then good. However, if my initial is 10 and my final is 20, then delta t is 10 and tf is 20. Okay, so as long as your initial is 0, then you can drop the delta t. I told you all this yesterday, didn't I? Yeah, whatever. Okay. Next tip. Anytime you're looking at equations with velocity, there is a big difference between velocity without anything and velocity with something. Okay, so if I have a subscript on velocity, it's not like v and vi are going to cancel. Okay, that's never going to happen. Okay, now delta t can cancel with tf, right? Because that same thing, same difference. Okay, but v and vi not going to cancel. All right, so let me walk you through this process. This is super easy, super easy. Y'all are going to say, oh man, you made this seem like a big deal. It's not, promise. Okay, so I have two equations. I'm going to select one, and what was I solving for, A? Yeah. Okay, so I'm solving for A, but it told me I didn't need a TF. So you see, I have all these T's, and I need to get rid of them. Okay, so this one, to solve this equation for TF would be a little bit of a nightmare, but this one's not so bad. Okay, so I'm going to take this equation and I'm going to solve it for TF. Okay, remember TF is the same thing as delta T most of the time. Okay, so I just multiplied both sides by TF. I'm solving for TF, so now I want to divide by V. Alright, so I get that TF is equal to delta D over V. Good so far, right?
Yes.
Okay, this equation has everything I need in it, but the only issue is that it has TF. I don't want TF. So if I take this expression for TF and plug it in everywhere I see a TF, then TF's gone now. Okay, so let's do that. I get delta D is equal to VI TF. Okay, so TF is delta D over V plus 1/2 ATF squared. All right, TF squared means this whole expression has to be squared. Okay, y'all see that? All right, so I'm solving for A. So the first step to solve for A is going to be to move this expression here over. Okay, so I'm going to subtract that from both sides. And so I get delta D minus VI delta D over V is equal to, I'm going to do a little math magic here, delta D squared over 2V squared times A. Did I follow that? I just rearranged the letters a little bit. I distributed the square and put that on the bottom. I did that to make doing the reciprocal easier. Okay, I'm solving for A. So since I'm solving for A, then I want to multiply by the reciprocal of the whatever that term in front's called, the coefficient. So I'm going to get 2V squared over delta D squared. Sorry, I ran out of room there. And so A is going to be equal to, and we're going to do a little simplifying in a second. Sure. Boom. Alright, so I see a little bit of simplifying we can do here. I see I'm dividing by delta D, and then I have delta D in both terms. Okay, so I can get rid of this squared and then cancel out the delta D's. Okay, so my acceleration should be equal to 2V squared over delta D times 1 minus VI over V. Okay, sure, I could put that on your equation sheet, but to be honest, you're probably very, 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 very rarely going to use that, and so it would just kind of jumble up your equation sheet anyway. So, to me, most of the time we're just going to use one equation, but very seldomly we will need to be able to do that. We good? I'm going to do one more example. All right. Develop an equation that has the variables d, v, omega, and delta. And I have d equals r theta and v equals omega r. And a go. Okay, so looking at this, the superfluous or the extra variable is going to be r, okay, is going to be r. So if r is the extra variable, that means I want to solve for r. All right, so it doesn't really matter which one in this case because they're both pretty easy to solve for. Which one? What did it tell me to solve for? Solve for d. So since it tells me to solve for d and this one's already solved for d, then I'm gonna solve this one. Make sense? Because there's no reason to solve for d twice. Okay, so I'm going to divide both sides by omega. And so I get r is equal to v over omega. Substitute it in. And so therefore d is equal to v over omega times theta. That's an easy one. I should have started with that one.
Yes.
What time is it? What time do we get out of here? Oh, we got time. We have time. Okay, let me give you all one to try. So try that one. Super easy. Super easy.
When we do this for like work and stuff,
Mhm.
we'll have to find the equations ourselves, right?
Yes.
When do we get this giant equation sheet?
It's not that giant. It's 50. Well, now I was going to ask you, would y'all prefer me just go ahead and give you all 50 of them, or typically what I've done is given a blank equation sheet and we just kind of fill it in as we go,
No,
So-
No, that's good.
because that way you never have any equations you don't need. Because
That's very good.
so
not very messy handwriting.
how about this? I'll make both available.
Yes.
No. How long did it take you to type this thing up?
Too long.
I can tell.
Two more.